Hi all, in today's video we're going to go over the solutions to Progress Check 3. Okay, so our first question we've got to use logarithmic differentiation to find dy by dx given the function y equals x to the power 2x cubed plus 1. Okay, and we're given 5 marks. So logarithmic differentiation, okay, what we do is the very first thing we do is we take logs of both sides. So I'm going to get log of y on that left hand side and I'm going to have log of x to the power 2x cubed plus 1 at the top there. So I've just took logs at both sides, okay? Now what that has allowed me to do is this awkward power that's on top has allowed me to bring that down to the front using my powers, to use my rule of logs. Okay, so that's going to be 2x cubed plus 1 multiplying log of x there. Okay, now I'm ready to differentiate. So on the right hand side I'm going to have a product rule. Okay, so I'm going to have my first term being u equals 2x cubed plus 1 and u prime, I'll work that out in a second. Okay, v is going to be log of x, and I need to differentiate both of them. So if I differentiate u, first of all, I'm going to get 6x squared, and if I differentiate, I get 1 over x. Okay, so I'm going to use the product rule, but however, I need to remember to differentiate the left hand side as well. So if I differentiate the left hand side, I get 1 over y, but because I'm differentiating with respect to x, okay, and y is a function of x, I get dy by dx next term. Okay, so I'm going to do the product rule on the right hand side now. Okay, so that's going to be uv dash, sorry, so it's going to be u times 1 over x. That means everything on u is going to be divided by x, so it's going to be 2x cubed plus 1 over x, okay, plus v times u dash, that's going to be 6x squared multiplied by the log of x. Okay, so there's nothing there I can really tidy at this minute. So in order to get dy by dx on my own, I need to multiply up by y. So it's going to be y multiplied by everything here. Okay, so it just takes maybe a while to write this. Let's try this. Okay, however, I know what y was. Y was the function I started with, so it was 2x to the power 2x cubed plus 1, and that's going to multiply everything in here. Okay. There's not anything else I can do with this due to the sort of nature of the function I was given. There's not anything that can tidy up. However, that is my final answer. I've expressed dy by dx in terms of x's only. Okay, there's no more any y's in my function. Okay, so that's the answer to the first question. Okay, that's just the first one. We'll now jump on to the second question, okay, which deals with graphs. So, part of a straight line is shown the function f of x there. Okay, and we've got 3 tasks we need to do. So, part A, we need to sketch the graph of f of the inverse function of x, so f to the power -1, that's the inverse, showing points of intersection with the axis. Okay, so that's the key thing to pick up our marks. Okay, B is then given a function f of x. If we add a constant k onto it, what value would make it an odd function? And C, we're talking about absolute values here, so we're thinking about a graph as absolute values, and it's going to shift as well. Okay, so we'll deal with that one at a time. So starting off with A. Okay, so what I know on my graph is I've got the 2 coordinates on my graph, 0, c, that's the y-intercept, and I've got the coordinate 2, 0, it cuts through there as well. Okay, now if we are wanting to have the inverse function, okay, of x, well, if I go up to my graph, what that actually means is it means that we reflect everything on y equals x, so everything that's on there gets reflected on this, and everything that's over there will get reflected on that. In other words, what happens is our coordinates switch. Okay, so that means that 0c, if I want to find the inverse, it's going to become c0, and 2, 0 becomes 0, 2. So if I was to sketch this, x and y is up there. Okay, c0, okay, so that's going to be along here somewhere, c, and 0, 2, I'm going to get the coordinate 2 up there, and my line now goes like that. Obviously it'll be straight, obviously a lot harder for me to do this on this, but you'll be able to draw a straight line there. But yes, I get a straight line there that goes from 2 on the y-intercept down to c. Okay, so they've been swapped over. So that's me, got my 2 marks, I've got the shape of my graph, and I've labelled my axes where they cut as well. Okay, they've intersected the coordinates. So that's part A done. We'll now go to part B. So I now think back to my f of x function. Okay, and my f of x function means that I want to shift it so that it becomes an odd function. Okay, so what my f of x function, just to remind myself, okay, basically was f of x looked like that there. Okay, c was up there and 2 was there. Now what an odd function would look like would be that. Okay, that's what an odd function would be, is where if we rotated it, I would get the same thing back. Okay, so you see here the key thing is I would need to go through the coordinate 0, 0, I need to go through the origin for this to work. Okay, so in order for this to shift, I need the y-intercept to be at 0, so that means I need to bring this down. Okay, and what I need to do is I need to bring this down a value of c. Okay, so if I bring that point there, c0, down 0c, sorry, down a value of c, it ends up at 0, 0, which means I get that there. Okay, so that means that k, okay, so f of x minus c works, therefore k equals negative c. That was the value that we were given. It's k, we know it has to be negative c. Okay, so that's the property of odd, that if we rotate it at 180 degrees, we get the same picture back. So in other words, it's got to be sort of diagonally opposite each other. Okay, and we'll now go on to the last part, which is c. Okay, so c is telling me I want to find the exact value of h when it is the absolute value function. Okay, so if I just start with my absolute value of f of x, okay, so starting off with my function I was given, okay, then what it would look like is c would be there, okay, 2 would be along there, and what would happen is it would bounce, okay, it wouldn't go, that's not a very good bounce, let me try that again, it would bounce back up, okay, that's what would happen, okay, so it wouldn't go down underneath the graph, absolute means we stay positive, so it goes bouncing back up. Now if I want an even function, okay, that was odd up there, so if I want an even function, what this will look like is that it should look like this. Okay, so what happens on the left hand side equals the same as what happens on the right hand side. So that's what needs to happen. So that means that this needs to get pushed over 2. Okay, that means I am moving over positive 2 in my brackets, so that if I'm thinking of the graph f of x plus h, the absolute value, therefore h means it would have to be 2. It had to have shifted over 2 in order to get from 2 down there along to 0 there. Okay, so that's what these were for. So they were 2 marks each for part A and part B. Part B was just a 1 mark question. Okay, so now move on to question 3. So matrices are defined as the following. First mark, we're going to find a squared, so let's do that first. So a squared is going to be 4p negative 2, 1, and it's going to multiply itself. So we should know how matrices work when we multiply them. We do, the first entry is going to be the first row times the first column, okay, of the second matrix. Okay, so it's going to be 4 times 4, that's going to be 16. P times negative 2, which is negative 2p. So that's my first entry, 16 minus 2p. Let's do the first row and the second entry now, so we're going to be along here. So 4 times p is 4p. Then we'll go p times 1, which is plus another p there. Okay, so we'll tidy that up in a second. Next, we'll go to the second row with each column now. So negative 2 times 4 is negative 8. And that's going to take away another 2. 1 times negative 2. And on the last bit, negative 2p. And we're going to get plus 1. Okay, and if I tidy that up, I get 16 minus 2p. I've then got 5p in there. I've then got negative 10, and I've got negative 2p plus 1. Okay, so that's my final answer. Okay, try and make that a bit more obvious, plus 1 for a squared. So that's 1 mark there. Okay, so now after we've got a squared, we can now go forward with the rest. So find the value of p for which a squared is singular. So, okay, if a squared is singular, then what that means, it means the determinant of a squared has to be 0. Okay, that's what we need to, that's what we know if it's singular. Okay, the determinant of a squared is 0. So what I'm going to do is I'm going to work out the determinant of a squared. Okay, so that means I'm going to do diagonal, so that multiplies with that. and it's going to take away the other diagonal of the reds there. Okay, so it's going to be the blue diagonal multiplied to each other, take away the red diagonal multiplied by each other. Okay, so we'll do that just now. So that means I'm going to get the bracket 16 minus 2p multiplied by negative 2p plus 1, take away 5p times negative 10. Okay, and that has to equal 0. Okay, right, so tidying this up. Okay, what you eventually end up getting is you end up getting 4p squared, and then you get negative 32p. Then you also get another negative 2p, and you get positive 16. Okay, and the last bit here, that negative and that negative cancel, so I'm going to get plus 50p, and that equals 0. Okay, tidying up even further, so I'm going to get 4p squared. That's going to give me, if I tidy up my p's, that's going to give me plus 16p plus 16 equals 0. I can divide everything by 4, so I'm going to get p squared plus 4p plus 4 equals 0. That gives me two brackets. I'm just going to go up here and do it. It's going to give me two brackets of p plus 2 and p plus 2 equals 0. Therefore, my answer has to be p had to be negative 2. Okay, in order for that to work. So that's the value of p that would have made this a singular matrix. Okay, so that's part B there. Okay, we get 2 marks for that. And the last part we're going to go to C. So what that's saying is, okay, find the values of x and p such that you get 3 lots of A transpose equals B. Okay, so that's what we're asked to show. Okay, that dash there means A transpose. So A dash is the same as A to the T, which means the transpose of A. Okay, so that's what it means. What the transpose of A is, okay, we'll do this first. So if I'm working out A transpose, basically the rows of A become the columns of A. Alright, that is basically it. Okay, so my first row was 4p, so that's going to be my first column. My second row was negative 2 and 1, so that's going to be my, sorry, that's my second row, that's going to be my second column. Okay, so that's what A transpose is. But if I want to do 3 lots of that, just multiply within by 3, so it's going to give me 12, negative 6, 3p and 1. And what that says is that equals a matrix that was B, which is x minus 6, 1 and 3. Okay, that's not right. I've made a mistake there. I've not multiplied this bit by 3 first, so that was silly. And you can see that a lot of this matches. The negative 6 and the 3's match each other now. Okay, so that is good. Okay, so that's what my B matrix was, and I've shown that that equals 3A prime. Okay, or A transpose. So now we can compare coefficients. Okay, we can see that x had to have been 12. Oh, not 16. Start that again. Not having very good success today, folks. Yep, x equals 12 there. And if I now solve for p, I get 3p equals 1, p equals a third. Okay, so those are the solutions to Progress Check 3. Please watch this video, and when you're doing this, make the corrections that you tried. Okay, read through it. If you don't understand anything, please let me know and I can go through it further. Okay, thank you.